right, so hello everybody. Thank you for joining this webinar on how Piezo Haptics enables the next generation of touch HMI in mobile and wearable device. We are really excited to have you on board today. My name is Nicholas. I'm a product marketing manager at Boreas Technology, and I'll be your host for today. So just before starting the presentation, I just wanted to cover a few technical details with you on the platform we're using today. So as you can see, we are using Zoom, and this allows you to ask some questions. So you may find the Q&A button either at the top or below your screen. So you can type some questions in there at any times during the webinar. We'll try to answer those questions right away or at the end of the presentation. The webinar will also be recorded, and we'll send you the link shortly after the presentation today. So let's get started. So today's presentation will cover many subjects, but first I'll introduce you the speakers for today. We'll also cover some UX challenges in consumer electronics, cover also a small partnership background between the companies that will be presenting today. We'll talk about a smart surface and our latest released Nexus Touch technology. We'll also answer some frequently asked questions that we receive from customers, and at the end, we will answer the questions we will receive on the Q&A section. So today's speakers are Simon Chaput, founder and CEO of Boreas Technologies, a fabless semiconductor company commercializing power-efficient piezo drivers, mainly for haptics. We also have today Gregor Mittelsinker, the principal and co-founder of Luft, a UX design, industrial design, and mechanical engineering product development firm. And also present today, we have Sonia Brown, Senior Marketing Manager at TDK Electronics for all the piezo devices. So without waiting, I will transfer the presentation to Gregor.
Thank you, Nicholas. Can you hear me?
Yep.
Excellent. So you're going to go back and forth on the slides, right? Because I don't know what. Okay, perfect. Go to the next slide. I wanted to make a quick introduction, all about haptics. Haptics have been around for a while, and I would say localized haptics are a newer thing, but really, where is this all coming from? What do we use smartphones these days? And I think, the processing power, general availability, and application layers have really made smartphones the Swiss Army knife of consumer electronics. They really are in every part of our daily lives, and really have taken over multi-functions that have been discrete devices in the past, from gaming platforms to cameras to flashlights to music players, just to name a few, to and it's kind of like more and more sensors are in devices that really enable new use cases. If you go to the next slide, I think it's important to understand that with this multi-layered approach also comes a challenge for UX designers to really capitalize on the power of the device. And as we're seeing more and more phones becoming kind of big bricks of glass that get larger and larger, the buttons are getting pushed to the edges, and really the feeling of the device is not as haptural as it could be. And I think there, especially with localized haptics, there is kind of the next generation where we see really a much bigger evolution in user experience design, kind of driving the haptics again in smart devices. Want to remind everybody, I know this is going back in memory lane, if you go to the next slide, where we all came from. I'm a pretty old guy, so I remember when RIM actually launched the BlackBerry, but back then it was really the haptics was a principal driver of technology back then. And then really as products evolved from the Sidekick, kind of really combining haptics with larger screens all the way down to kind of the classic BlackBerry. We still had this kind of big rail of real buttons to give you that feel when you're interacting with the device. as you all know, with the iPhone, this all got swept away, and we're really more like a haptic-less environment these days. I think there've been attempts of recreating haptics, and especially as you're going into the future, with wraparound displays and edge displays. I think there's more and more of a need to give that real estate a more of a purpose, especially, and I'm going to make a quick introduction also. Get to the next slide. As mechanical switches are really highly illuminating, virtual buttons are evolving. But as you know, the feel and function of virtual buttons have been subpar, to say the least, in the future, in the past. And we're really looking at that physical real estate to getting smaller and smaller. Therefore, haptics can really enable UX designers with novel user interfaces and just touch feedback. And it's interesting also that you see at the same time also, if you go to the next slide, that a typical way of holding a phone is really on that edge as phones are getting larger. So like the natural interface with a phone is through that edge, along, of course, with interacting with the screen, but also gaming is becoming mobile gaming is much more important. Actually, Xbox and everybody's trying to kind of also capitalize on the popularity of smart devices to extend their reach. Therefore, becomes kind of this next realm of interfaces is going to be probably more of a mobile platform than a set-top box with a dedicated controller. If you go to the next slide, I think really the edge has become a very important ground for HMI interactions, and I, as a designer, I'm very excited about kind of localized haptics and what these new technologies can offer, and really kind of capitalize on. If you go to the next slide, kind of enabling the future of new forms of tactile UX. Multi-layered interactions are now really becoming more possible. This idea of input reassurance, I think, is often overlooked, especially as you're looking at current touch interfaces. And then, of course, lots of times you don't want to power up your screen if you want discrete notifications. UX designers can leverage haptic feedbacks for that as well, very effectively. Quick introduction and time check. How are we doing, Nick?
We're doing good. Yep.
Okay, excellent. Okay, perfect. So I'm gonna, have the next section is actually kind of an introduction of where Boreas is coming from. A little bit of a background. I think, as you know, haptics have been around, and I think Boreas is really gonna try to, with TDK, kind of really own that technology on a much bigger and higher fidelity scale. So, Nick, who's speaking from your team on this side? You?
So I will speak. Thank you, Gregor.
Oh, okay. Thank you. Okay.
So Nicholas, if you can go to the next slide. So let me first start by introducing a bit more Boreas technology, since we are a newer company and for people who didn't work with us in the past. So where do we come from? Well, back in about 2013, 2014, I was put in connection with people at General Electric who were building a cooling solution for laptops and tablets. The problem they had was that the electronics for the cooling solution was overheating itself. And that is because they were driving piezoelectric actuators with what was available at the time in terms of piezoelectric drivers. And based on that, I developed a technology, Cap Drive, which is miniature, very low power, and offer high performance to drive piezoelectric actuators. And so while it didn't start with haptics, we soon realized that haptics was actually the best market or best application for that technology. And that's when Boreas was founded around 2017. And since then, we have been working to transform that originally academic technology into a portfolio of products that are qualified to go into mass production in many of the consumer devices that you are working with every day. Next slide. So what is Cap Drive? Well, Cap Drive has three main attributes that are very useful for you. First, it's the lowest power solution to drive piezoelectric actuators. And if you compare the haptic power required for, let's say, the same haptic effect over different technology solutions, such as LRA or Piezo with different other piezo drivers than Boreas, we can show that in the lab that we consume about 10 times less energy. And that is very important if you're thinking about a smartphone, a wearable, a stylus, where you're trying to basically enable a better user experience in a very small form factor with very limited access to power. The other thing is that it's a dual purpose device, which means that you can use it just as a haptic driver to generate localized haptic sensation, but you can also use it as a sensor front end, which means that you can detect how much pressure is applied by the user on the surface you're interested in, which means that in any applications where you are looking for kind of button replacement type of application, you only need a single device that can do both the sensing and haptic, similar to a button, but with better performance and user experience. And finally, from the ground up, the technology was built to be viable in high volume applications and small consumer devices, which means we have the smallest footprint for this type of product on the market. And when you combine all those three features, what it means is that you can really focus on building the best user experience for your product while still meeting the other requirements such as power, size, or cost requirements you may have in your product design cycle. And on that, I will let Sonia from TDK introduce a little bit more piezo actuators.
Sure, thank you, Simon. So I just want to touch on the hardware behind the Boreas drivers. We are a company that's been built on piezo type materials, and we do a lot of different products with these materials. When we looked at getting into using the piezo actuators as haptic devices, we really looked at what was on the market, what was already being used, what some of the limitations were, and to determine if we had something to add here. So we've come up with different ways during this COVID time to show you, rather than let you feel what our haptics feel like, to try to give you a visual. So if we look at something very basic like the ERM, which is really just basic haptics, mainly for notification, you get vibration for notification. You may not know what it's for, but it could be a text, an email, it could be anything, but you're going to get a basic haptic notification. Then you get the LRAs, the linear resonant actuators, that are actually give you a little bit more control, a little bit more flexibility. These we would call standard haptics. You can get a basic click is possible. It takes a lot more energy to do that. It has a small bandwidth still. And then you get into piezo electric actuators, and what that enables is high definition haptics. You get a very fast response time. So as soon as you touch the screen, you get a feedback that you've touched it. And it has a high bandwidth, which means that you can go from a single click to get a button like click, or you could do several waves that would give you, or pulses that would give you different types of vibratory feedback. So you can get millions of different types of feedback from a piezoelectric from one single product. If you'd like to go to the next slide. So graphically, what that looks like is, if you're looking at using the ERM, that really gives you, it's not possible to do just specific haptics. It has a slow response time, and there's longer oscillations which take up more of your power consumption with undefined waveforms. And looking at LRA, that gets a little bit more flexible. So you still do have that long system oscillation compared to what you can do with piezos, still a slow response time. Then if you look at the power hab solution, it's very possible to do the single pulse to get a single pulse click. We have very fast response time, and the oscillation is much more controllable with this technology. Would you like to go to the next one? So just to give you an idea of what the parts look like here, we have solutions for all types of haptic applications, and solutions for all needs, starting with our piezo hapt type products, which are more of a single layer with used in low masses, OLED displays and those sort of things. And then our power hap series, we have square type power haps, we have lateral power haps, and then the most important to looking at the Nexus Touch and what it enables. The Nexus Touch is the very small mini lateral type power haps. And these are used for side button replacements, for all types of products. And they can also be used in button replacements and other types of applications. So all of these products, if you put the Boreas products together and the TDK products together, what we've done is put together a few reference designs that will help you with your products. So what we offer basically is an automotive display, also with the help of another collaboration partner. And that uses a very large, or our largest lateral part. It's not very large, it's just our largest part. And then the others would be using the mini laterals. So the Piezo active pen, where you can get the feel of writing with paper on paper and pen, or with a pencil on paper when you're actually writing on a glass tablet. We have several types of smart buttons that we're working on. We have some reference designs there. These can be used anywhere. They can be used in industrial, they can be used in automotive, they can be used in consumer products, but anywhere you have a mechanical button, these would be the virtual or piezoelectric buttons. And we also have what we call a PHE, which is the Piezo Haptic Engine. And this is for notification in things like wearables and smartphones. So this gives you the vibratory notification. And then our latest reference design is the Nexus Touch smartphone, which I'll hand this back over. But this is what we're going to touch on today. What we're really going to focus our webinar on today is the Nexus Touch.
I was muted, sorry about this. I think, especially as we're talking about HMI evolutions, I think Nexus Touch really is offering a whole nother level of being able to introducing kind of smart surfaces in devices. Right now, I think the technology is built around the edge, but obviously, as it could be applied in other areas. If you go to the next slide, I think, when you say what is a smart surface, we envision as a UX designer a future where, any surface could become piezo haptic enabled. And this is really just the starting point of a UX revolution where, physical buttons are getting more and more replaced with haptic touch buttons that have distributed feedback across a larger interface. I can see lots of applications in the medical device space, in wearables, in car interiors, et cetera, et cetera. Maybe Simon, you might be best suited to kind of walk us through like Nexus Touch's benefits. And there was also a question in the chat about how the low power is right now achieved in the platform. Maybe you can also address that as well.
Yes. All right. Thank you, Gregor. So let's start with Nexus Touch. So first, let's define what is Nexus Touch. So Nexus Touch is a solution that enables to blend gesture detection, force sensing, and localized haptic inside a single technology. And what it enables, if you go back to the concept of smart surface, is that any surface that in the past was basically just a hard surface with no smart can become a surface where you can either click, swipe, tap, and that can trigger different interaction in the system it's used in. And then I'll come back to the low power at the end of the presentation. But if we go to the next slide, Nicholas. So why would you need Nexus Touch? Well, we think that in the past, as Gregor mentioned at the beginning, there was basically a single device for every use cases. So you had a camera, you had a telephone that was able only to call. There was a gaming console where you would play gaming. But today, you basically have a single device that is trying to do all of those applications. And unfortunately, the user experience is pretty much the same that if you are sending a text message, calling your friend, taking a picture, or playing a game on your phone. And what Nexus Touch brings is that it can customize the user experience for each application so that it just feels right when you operate your device and you prefer to work on that device instead of trying to find another device to do your work. And Nexus Touch really enables that flexibility of defining a user experience based on the application, not with no limitation of the actual hardware used. And so if you go to the next slide, Nicholas. So these are all the components required for a Nexus Touch system. So the important part is not really all the subcomponents, but it goes all the way up from the software, which is typically custom defined by the phone OEM or third-party app developers. And then it uses a bunch of standard components from the OS that could be Android or iOS, or even the newer Harmony OS from Huawei. System on chip, a driver IC, and a piezo actuators. So all of these components are standard. And then the mechanical integration is also a very important part. That's the interface to the outside world, and it's typically designed at the same time as the industrial design of the device. So that is also handled by the phone OEM. So what you can see here is that mostly we're putting together standard components, but once you've put that into your device, then you can just change your software and completely change the user experience and how the device feels in the end of the user. And we think that is a very big value add for any products in the future. And when we provide reference design for Nexus Touch, we can help our customers to really go through all of these components and provide examples on how to do all layers. So you go to the next slide. So this is an example of the Nexus Touch software. So really our goal is that using Nexus Touch is as transparent as possible to the user. So we develop internally all the Android framework for an Android ecosystem phone, for instance, that is required to make it work so that the user experience people can concentrate on building the user experience, and everything else is just as designing a normal phone or a normal product. If you go to the next slide. So there are several different use cases for a Nexus Touch in mobile device, and even in more than mobile device, but we'll focus on phones for today. So the first one is really just button replacement. So in the most basic way, when you click on the side of your phone, you want it to feel exactly as a button. So you can just click on it. But once you have Nexus Touch, you can also do things such as swipe on the button region, which enables you to, let's say, increase your volume or scroll through content that is displayed on the screen. And with that, you also get localized haptic effect, which means that your click can be can feel different from application to application, and you can also change that rapidly. And finally, Nexus Touch is compatible with what we call seamless design, which means that if you like an industrial design which has kind of typical buttons, then that's okay. If you want a industrial design where the buttons are hidden underneath the surface, then that's also possible. It's now that becomes more an industrial design choice from product to product. A clear example is really a DSLR camera experience. So I think we can all agree that today we can take breathtaking pictures with our phones. However, we can probably also all agree that the user experience of taking pictures with our phone is far from being optimal or nice. Typically, you need to swipe your fingers in the middle of the screen to change mode or to focus. It's definitely not ideal. So what Nexus Touch could offer in that type of application is really to put the controls on the edge of the device on the top where your fingers are naturally meant to be. And then you can just swipe for zooming in or zooming out. You can swipe for changing modes of the camera. You can also, let's say, press lightly to set the autofocus on the camera and then press strongly to really take the picture. And that all brings back a more natural user experience to a phone that is used in a camera mode. And then if you go to the next slide. But then once you're finished taking your pictures and you want to play a game, you don't really want to feel the same thing on your index. If you are driving a car in a racing game or shooting of a firearm in a one-person shooter game, you don't want the button to feel the same thing. Gaming is all about immersion. And what Nexus Touch brings is that it enables to change the experience of the user based on the games and the action it does. And then instead of being limited to, let's say, 2 buttons on each shoulder area of the phone, you could have 3 virtual buttons. You could also start to detect swipe in either direction to change mode or change firearms or change cards in the game. And so really that enables a bunch of possibilities that were not possible for game developers before.
Yeah, before you jump in there, I think there's something important that came up in the chat, this idea of localized haptics. So, obviously we know there have been haptic engines in phones before where there's a centralized engine that creates basically feedback, but that feedback is not localized. So if you're hitting that edge, your whole phone starts rattling. It is not a very true experience and really does not satisfy kind of the haptic desire that your button pressing would actually need to kind of localize it in that area. Therefore, where I think this technology has a much better advantage in kind of bringing haptics where it matters, where you actually have your finger at the moment of interaction.
Yeah, that's an excellent point, Gregor. And I think for everybody, it's easy to relate that if you press on something with your thumb, you don't want to feel the haptic in the palm of your hand. This is just something that feels wrong. And I think there's many cases where phone manufacturers have tried to remove the physical buttons, use these type of technologies, and then they basically failed in the market because the haptic was not localized and it just break the user experience.
We have another question relevant for Nexus Touch. So someone is asking if the phone case will need to allow direct contact with the phone edge.
So no, it's not necessary. So basically, that's another advantage of Nexus Touch. It's based on force. So a little bit like current phone cases have a weaker spot where the buttons are so that you can press on the buttons on the user. As long as the as a case for the phone is a little bit weaker where the Nexus Touch is implemented and the force can be transmitted to the phone frame, there's no need to be in direct contact with the phone frame for the technology to work.
So questions are coming in. We just have 3 final frequently asked questions, and then we'll follow up with the attendees' questions. So maybe just to create a discussion between all panelists. So we kind of touched the subject a little bit earlier, but what's the difference between piezo haptics and legacy technologies?
Yeah, I think maybe Simon should talk about this in more detail, but it's really this idea of moving the touch where you need it, not the touch, where the phone has space for an engine. It really is that localized sensation. Sonny brought this up. Everybody on the panel should probably reach out to Boreas and TDK to get a reference design and have it in their hands. But I think the first time you hold it in your hands, you realize how different it feels than the current product on the market, where just mimicking kind of interactions seems very artificial, where the Nexus Touch solution is much more like a real button. You can't even believe it's not a real button when the first time you feel it.
Sorry, I'm muted. I would add to that, there are a couple of differences. So one of the most important, obviously, is the user experience. So we have very, very small devices that can offer very powerful feedback. So the feedback that you feel can be very powerful, it can be light, it can be anything that you want it to be. So the actual biggest thing we have is just the flexibility to make this what you want it to be, to make your user experience exactly what you want your users to experience. The other thing is that when you talk about battery life, the more gaming that you're doing, the more bells and whistles that you're putting in, you have to be very careful about that they don't have to plug in 3 times a day to keep their power. So these are very power efficient parts. And I guess I think that's, along with what Gregor said, I think those are the major points that set us apart.
Mm-hmm.
Perfect.
So I think you talked about this in the beginning, but this idea of legacy technologies, maybe you can elaborate a little bit where also from like a physics perspective, the differences are between piezo and legacy technology.
Sure. So ERMs and LRAs have to be extremely large to give the same force, displacement, and acceleration that you would get from one of our extremely small mini laterals. So just the physical size between the two, if you're looking at the exact same feedback or close to the same feedback, is very large. So to get what you can get out of a mini lateral, the LRA and the ERM would have to be too big to fit into a phone.
And I think I would add that also the bandwidth and rise time are very important here, because they enable you to create widely different waveforms. And one of the use case where that resonates the most with people is we do have a wearable examples where we recreated the feeling of a heartbeat, and it actually feels exactly like if you were touching the heartbeat of somebody. And you can see that in application, let's say in VR or AR, where you want to communicate with virtual world, the ability to recreate those type of sensations, which are not possible with legacy technologies, will really increase the experience of the user.
Mm-hmm. And Simon, there's a question in the chat from Don. I think also maybe you can come across that. What is the detection method? The sensor is actually the same, right? It's one product. It's one component.
Correct. Yes. So basically, if you are not familiar with piezoelectric actuators, they are based on piezoelectric materials, and the main properties of that material is that if you apply a voltage to that material, it will generate a mechanical strain, and that will create the haptic effect. But the inverse effect is also true, which means that if you apply pressure on that material, it will generate a electrical signal. And based on that, with the good control algorithm, you can really use the material in both directions, meaning that you can drive it to generate haptic, but you can also read it to know how much pressure is applied by a user, for instance.
Mm-hmm.
All right, thank you. So maybe we can jump to the next question. So why is Nexus Touch better than other button and smart surface solutions?
I think we can see that in the past few years, there's been a few attempts especially in the smartphone space, where they removed mechanical buttons, or they try to increase the amount of interaction you could have with the edge. But typically, they either have very small amount of gesture that could be recognized, or they didn't have localized haptic. And I think the feedback was typically relatively poor in terms of the usability of those devices, because as we mentioned in the past, input reassurance is something that is basically visceral for humans. When you press on something, you want to know that you press on it, and you need to feel it on the right finger. And what Nexus Touch brings is really the ability to do advanced gesture, but do not compromise on this input reassurance, and provide localized haptics that is required.
Perfect. And before jumping to the audience questions, why does increasing control capabilities on the side of the device is important?
Yeah, I think I want to jump in before Simon even goes technically. I feel like as a UX designer, you always struggle to give buttons a meaning, and we all know how great it feels to have a real camera in your hand where you can focus, and you have this like click 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 feel. The great thing about Nexus Touch really is that you can actually feel that ripple effect on the edge, right, as you're sliding a button over it. And that's a game changer for me as a UX designer, where I'm not relying too much on a physical button anymore. But the only thing that stops my UX creativity is really my imagination at that point.
Yes, and that's great. And also another point is that typically when you hold your device, the natural feeling is you'll have your fingers on the side of the device, which means for small interaction with the device, it's much more natural to, let's say, move your thumb across the side of the device than to move it and try to go everywhere on your screen. And so really Nexus Touch can enable you to easily control the screen by just sliding your finger on the side of the device where it is naturally. And then it also enables you to have a completely visible display, which means you don't have to have your finger in front of the display to interact with the device. And finally, I think one other interesting part is sometimes it's frustrating when you are doing, let's say, sport activities, and you just want to check your phone. If you happen to wear gloves or anything that makes it impossible to use a touchscreen, Having the ability to control some basic functionality of your phones through the side can make it just much more user-friendly, so that you don't have to remove, let's say, biking gloves or gloves in the winter. So that's another advantage.
Great. So thank you. So we'll jump to the questions we received. So the first one, let me. So can you also use Nexus Touch underneath a touch screen and provide full force sensing with localized haptic feedback where your respective finger is?
Let me just read the question.
So I'll just start with from my perspective. So it is definitely possible to use these type products under the screen, and yes, you can get localized haptics respected to where your finger is.
Perfect. Simon, did you want to add something, or?
No, I think Sonia did just provide this.
Okay. Perfect. Other question we received. Do you have guidelines concerning the mechanical requirements for the installation of haptic actuators under a smart surface?
Yes, I
Yes.
think that's an
Sorry,
area where
go ahead, Simon.
both TDK and Boras can provide guidance. It really depends on the application. If it's a phone, if it's an automotive display, if it's a keyboard, depending on the application, there will be different mechanical guidelines. But definitely reach out to either Boras or TDK and can help us with your application.
Perfect. Is the piezo material lead-free?
So currently the material we use is a PZT material, and the P in the PZT is lead. But we have programs that we're working now and have been for the last 3 to 5 years on different materials like KNI and different things like that that are lead-free. At this point, we do not have in production a lead-free piezo actuator for haptics feedback, but that is something that we are working steadily on.
Okay, thank you. And the last question we received, how does piezo haptics have higher bandwidth compared to the traditional ones?
So if you look at how a ERM or an LRA is constructed, typically it's all optimized so that you can move a mass at the resonant frequency of the system. And so typically for an LRA, let's say the system will be optimized so that it can resonate at 200 Hertz. And as soon as you try to operate that actuator outside of that frequency range, the strength of the actuator will be very, very low, and so not useful for haptic. In the case of a piezo actuators, we don't use resonant frequency, which means we really just produce strong force, and we can produce that force at any frequency. So if you need a 50 Hertz waveform or 300 Hertz waveform, it doesn't really matter for the piezo actuators. You can just generate that and have the feeling that comes with it.
Thank you. I guess we're out of questions now. I don't know if the speakers want to say a few closing words on maybe other applications beyond mobile and piezo haptics and how it enables new kind of HMIs.
Yeah, before we jump in, I think there's one thing. I have a question for Simon. We talked about this at the beginning, but this idea of OS, basically haptic touch on Android or iOS notification functionality, but also this application layer. If I'm a UX designer and I'm not working for one of the big phone manufacturers, how do I use your technology in my work?
Yeah, that's a great question. So once the technology is implemented in kind of consumer devices and is available on the market, that will just become a traditional input device. So there's already input devices are defined in, let's say, an Android phone, such as the touchscreen. So that will just become, let's call it a second touchscreen that you can receive input from and also send commands for haptics. And this all this part that needs customization in software, the low-level part is done by Boreas, and then it will be integrated into the OS directly. So from a user experience perspective, the goal is that it will be very transparent for the user, for the developers, so you can just concentrate on what's the experience you want to build, and then don't bother about the low-level implications.
Perfect. Yep. So, well, I guess this is it. If
I know we wanted to talk about other applications, right? Sorry, I was disrupting you.
Yeah. Well, go ahead. So,
Simon, you want me to talk or?
Yeah, well, I guess you can start with different applications, and I can add stuff after that.
Right. I think because this was very much smartphone focused, and Boreas is a when I started talking to Simon, I'm like, well, I want this in cars, and I want this in medical devices, and I want this in any touch interface that I can think of because it's so great. And obviously, it's probably the smartphone market is a very large market, so it's smart to focus on it first because you get it in one device and you touch a lot more UX designers than if you put it in a medical device. So but I think there's some obvious benefits in really bringing it into other devices, larger screens, cars. Maybe you talk about your experience and also what you've learned from customers where people really think there's a benefit with your technology.
Yeah, and I think if you look at what's happening in most of our applications around us, is that even in cars where typically we would just drive it around, now there's kind of thousands of different functionalities that you can control in your car. And we can see that in pretty much all applications where you have more and more functionalities to control, but still the same real estate or similar real estate to control all of those functionalities. So a technology like Nexus Touch, which enables to detect gesture in a very kind of small surface, enables to increase the amount of control you can have on those different features and make it very natural for the user to interact with whatever is the device they're using. Mm-hmm. And maybe if I can, I saw that the question about low power came back again, so maybe I'll take a minute to answer that one. So if you look at what a piezoelectric actuator is, it's basically, and this definition will be a little bit more technical, but it's basically a capacitive load, which means that it doesn't really consume any energy by itself. And in the past, before Boreas technologies, all piezoelectric drivers were built the same way. They were basically a high voltage version of a traditional amplifiers. And these traditional amplifiers, while they're great for inductive load like speakers or other type of loads, they're not optimized for piezoelectric actuators. What we've built at Boreas with CapDrive is a technology from the ground up that enables to provide energy in the most efficient way and also recycle all energy that is not used on the actuator. And that is what enables us to achieve such a low power compared to our competition.
All right, so we got a couple more questions coming in. So we have one. So for the automotive industry, so what type of interest have you seen for haptics use with automotive users? Especially in the interior displays, which seem to control all.
Yeah, so I'll take that one. Yeah, so we're working with quite a few tier 1 and OEM customers or potential customers in automotive for all types of applications. So it can be button replacement, say on an armrest. It can be button replacement on the power steering or your steering wheel. We've seen lots of different requests for very miniature displays that would fit in your steering wheel, up to 20-inch displays that would be on the in the center console. There's a lot of interest in the center console right now, so we're doing a lot of projects with center console. The biggest thing there is how do we keep motorists with their eyes on the road, not looking for the button to push. So as you take away these physical buttons that people can reach for and swipe across their dashboard and find the button eventually, and may turn the radio on before they get to the air conditioner, but they're finding buttons anyway. When you start going to the sleeker designs that the OEMs would like to do, which is just a very large console with all of your human machine interface there. So you take the buttons off and you've got a tablet, a big tablet or a big display in your car. How do we have people safely using that on the road? And that's where haptics comes in. As if you don't know where you are on that panel, you're searching, you absolutely have to take your eyes off the road to look for what you're doing on the panel. So what we're trying to do is help automotive makers make their dream of a sleek interior come to life by using haptics to help people find buttons and to let them know when they touch a button. So that's the big things I see in automotive. And we do have, I think someone was asking about reference designs. I think one of the questions was about reference designs for other applications, and that is one. So we do have a reference design for automotive display.
Right. And I mean, we do a lot of medical device development, and I constantly, challenge to come up with new ways of giving physicians feedback. Let's say you're inserting a catheter, to a certain level. Right now, you're looking at a screen that's, usually 6-8 feet away, and you're kind of navigating in the heart of the patient. If the capacitive touch feedback would actually give you kind of a resonance understanding how deep you are with that catheter would be really beneficial. Obviously, that's kind of a future technology, but
Right.
I think there's real merits beyond just kind of recreating a button, but also giving kind of new types of interface methods for people that need it on a daily basis.
Thank you. And maybe one last question. Does Piezo haptics works in other application, for example, tablets, pads, or other displays?
Certainly, I think we sort of touched on that before, but definitely you can, this could be scaled up or down from wearables, scaling it down to a wearable size screen up to the tablet size screen to the display size screen. It's all about bringing touch to a display, whatever size it is.
Perfect. Thank you. Well, this is it for today. I'd like to thank everyone for joining, and also our panelists for presenting today. I hope it was useful for everyone who joined. And I will add for the last minutes of this presentation, I will bring back the speaker PowerPoint page slide so you can see their email addresses, and feel free to reach out to either one of the panelists if you have any questions. So I'm going to share back my screen. So thank you everyone for joining, and wish you a wonderful rest of the day. Thank you.
Thank you.
Thank you.
Thank you.